Morning, everybody. We're just going to give everyone a minute or two just to get into the chat, and then we'll get started. So just sit tight for another minute or two. All right, so we're going to go ahead and get started. It was nice meeting you all yesterday. Really enjoyed class. Hopefully you did as well. What we're going to be doing today is I want to take the time to look over the two Google Form quizzes that you had, so one from Tuesday and one from yesterday. I saw that about 13, 14 of you have completed them. That means I'm missing between 6 and 10 people, so make sure you're completing those as much as possible, but thank you to those who have been completing them. Just two general notes before we get started. One, I see a couple of you are not muted, so make sure that you take this time now to mute yourself. The second thing is make sure to open the chat on the side. I posted it in Google Classroom, so the chat is right below the Hangout link. So I have that open for any and all questions, so I'll be referring to that often. So if you want to ask questions there, feel free. And if not, we'll get started. So I'm going to start with those two quizzes. If between now and then there are more questions from either of the handouts or from the assignment, anything at all, please just type it into the chat and I will take note of all the questions that you want to go over, and I will try to go over them all as much as possible. Okay, so take this time now, refer to the chat, open it up, and then type in the questions that you want to go over, okay? Okay, so we're on the second quiz right now. Feedback was pretty good on the first question. Which of the following polynomials is equivalent to the square of a binomial? So that answer is D. So the first one, to be a square of a binomial, you have to be a you have to have three terms. So the first one and the A and C do not have three terms, so they're automatically eliminated. B, the third term is not positive, so that's automatically eliminated. So before I even do any calculations, before I even verify anything, I've eliminated 3 of the choices, which is fantastic. Good news for me if I get this question on the final. Okay, question number 2, we have a long division. Like I said, we should be getting used to these problems now, so I'll do this one very quickly. It should be 1x cubed minus 22x squared. All right, so here what we are doing, ooh, it's nice and big. Remember, we're dividing here, first term by first term. When I divide this, it gives me 4x squared. When I multiply, I get 20x cubed minus 12x squared. I subtract. This gets eliminated. Negative 22 minus negative 12 actually gives me negative 10x squared, and I bring down the next term. This term gets divided by this term, so negative 10x squared divided by 5x gives me negative 2x. When I multiply, negative 10x squared plus 6x. So I have 41 minus 6. These go away. So 41 minus 6 gives me 35x, and this gets brought down as well. We divide this term here. This term gives me 7. When I do the multiplication, I get 35x minus 21. When I subtract, that gives me 51 as my remainder, giving me A as my solution. Okay, question 3 on the third quiz. Like I said yesterday, there was a typo or a problem with the answer. So we can go over it. If you got 4, that was the right answer to that question. Okay, so we can go over it quickly. So we have 5x plus 3, and we have 10x squared minus 44x minus 26. 10 page. All right. So when I divide this term by this term, I do get 2x. Multiplying gives me 10x squared plus 6x. When I subtract, this gives me negative 50x, bringing down the negative 26. This divided by this gives me minus 10. Negative 50x minus 30. I subtract, negative 26 minus 30 gives me positive 4 as my remainder. I have a side question. Are all these quizzes still on Classroom? Yes, they are. They are posted with the assignment. Okay, so whenever you see an assignment, there's a link with the assignment. Click on the link, and then you can access each of the assignments or each of the Google Forms. So that would be quiz number 2. Quiz number 3. We have here it's not working. We're good to go here. So on this one, we have 9. Alrighty. Always lots of fun when you have technical difficulties. So here we have bear with me, guys. We are good to go. All right. So here I have 9. I will figure this out. Do not worry. Do not fret. I am all over this, guys. All right, let's try this again. So here we have 9x squared y . 9x squared y plus 12y squared plus 15x squared plus 20x. So again, this is grouping. Take each groups and we factor out what we can. So here, when I factor this out, I can take out 3. I've done this twice. This is not where that goes. This goes here. So I can actually factor out 3y squared. What am I left with when I do that? I'm left with 3x plus 4. On this side, what can I factor out? 5. And I'm left with 5x, and I'm left with 3x plus 4. When I rearrange this, 3x plus 4 gets pulled out, and I'm left with 3y squared plus 5x, and this is factored. That gives me the third option. Question 3, we're going to save. We'll go back to that after we do the first couple of questions for the next topic, and then we'll come back and look at that together. Okay. Question 3 on the assignment. We'll take a look at that now. So I will be looking over these this afternoon, this evening, tomorrow morning to give you feedback. So just check that out. All right, so we've got a polynomial, we've got a rectangle. So here in this problem, there's 2 ways to approach this problem. One of them we have the tools for now, and one of them we'll have the tools for in a bit, but regardless, we do have the tools. So we know that area of a rectangle is length times width. So I know that 18x squared, talking what my area is, x squared minus 9x plus 9x minus 20 to be 3x plus 4 times something. I don't know what that something is. But if I just divide both sides by 3x plus 4, I can figure out what this something is going to be. Now, when I divide by 3x plus 4, we now know that I have to set this up as a long division. Following the steps of long division, we divide here, we divide here. So 18x squared divided by 3x gives me 6x. Multiplying here. These cancel out. 9 minus 24 gives me negative 15. When I divide again here, I get negative 5. Multiplying here gives me no remainder, meaning that I have this rectangle and the dimensions of this rectangle are, we have 6x minus 5 here, and 3x plus 4 here. If I want to find the perimeter of a rectangle, now this is Sec 1 stuff, I have 2 times the length and 2 times the width. So I know that the length, let's say, is 3x plus 4 plus 2 of what I just found to be the width. So here I can distribute this 2 into both of the different binomials. So 6x plus 8 plus 12x minus 10. Put my like terms together. So these two go together, meaning I have 18x. 8 and negative 10 gives me minus 2. And that is the polynomial that represents the perimeter of that rectangle. So when in doubt, just always start with the information that you know. You have the area of a rectangle. What's the formula for area of a rectangle? Well, you see it. Then plug it in. Plug in what you know, see what you're missing, and see what tools you have to use in order to complete the problem. Okay? All right. So, just making sure I got all the questions here. We got question 3 on the second quiz, question 3 on the third quiz, question 3 on the third quiz, number 3 on the assignment. All right, so I'll give you another minute. If there's any other questions that you want to go over on either of the handouts, we can go over them now. Otherwise, we'll jump into the new material. So I'll wait a minute just to see if I get any questions to go over, and then we'll jump into it. I'm hoping that we don't have questions because we went over it and we understood, and not because we didn't do our homework. That's the big, big, big hope here. Okay, so I'm going to take your silence, the radio silence and the chat silence, as we can move on and we're ready to do the new material. So just as a quick recap from yesterday, because we're going to be using these tools a lot today. The ones that we did yesterday at the end of class, the different methods of factoring. Okay, so we're just going to take a quick look at this again. So not division. The square of a sum, we have this perfect identity here. That whenever we have a sum, so a binomial that has a sum, the power of 2, we can just use this relationship to expand this. We also know that it works backwards. So if we see this relationship, we can move backwards. We do that with very careful paying attention to little tricks like this, which was actually not a perfect square, but had the appearance of a perfect square. We were comfortable, or we worked on working with these forwards and backwards. The same thing with the square of the difference. Only difference is we have a subtraction here instead of an addition. We worked on these once again, forwards and backwards, expanding it using the relationship in one direction or condensing it using the relationship in the other direction. Once again, we paid careful attention to little tricks when polynomials appear to be perfect squares, but they're not actually perfect squares. We talked about were difference of squares. So once again, we have this relationship where if we have two binomials, two conjugates that multiply, we get the square of the first minus the square of the second. So we worked on expanding these forwards and backwards. So when we had the difference of squares, what did it turn into? And when we had this relationship, how did we factor it? Okay, this is going to be a This one here is going to be super important and harder to identify because our brains don't always go to difference of squares. So try to keep that at the forefront of your mind. About specific types of factoring. So we talked about GCF factoring, where we were looking at different expressions and we were taking out greatest common factor. For instance, here, when I was taking out the greatest common factor, I would take out 6x squared y squared, leaving me with 2y minus 3x plus 4. So we're taking out the common factor from all the different terms in my polynomial. They're a little tricky. We have actually x plus y that gets taken out of both, and we have x plus y plus x left. And I have x plus y, 2x plus y. So always taking out what's common to all the different terms. And by grouping, when we had 4 different terms that we were working with, excuse me, and what we did here is basically we looked at what was common to each of the different pairings and GCF factored them like that. For instance, in this case, I can take out a 5x squared y squared, and I would be left with 3x squared plus 7. And in this case, I could take a negative 3, leaving me with 3x squared plus 7. Then I regroup. I pull this one out of both, and in the second bracket, what I'm left with, 5x squared y and minus 3. So that was GCF factoring. But in order to do GCF factoring, we needed 4 different terms that we could work with. That was where we left off. So we're going to pick up today. We're going to continue building our skills for factoring, and then we're going to see what we're going to be using them for. Okay? Feel free to jump in if you have any questions. So once again, you have the blank notes, filling in anything in the blue. So I'll give you a minute just to start filling in blue, and then I'll start after we filled it in.
Miss Swift, which package is this in, like note-wise?
This would be in class 4 notes that was posted on Google Classroom yesterday.
Okay, thank you.
You're welcome. Okay. I'm going to get started unless there are any objections. Any objections, just type quick in the chat, wait please, or something to flag me down to wait a little longer, and I will. Sure. We're going to go back to them. So the question was we didn't, or the comment was we didn't finish the last set of notes on class 3. We're going to go back to them. I'd like to do this first, and then we're going to go back to them in a second when we see what we're going to be using them for. Okay? Have not forgotten. We good to go? Okay. So we talked about GCF factoring. We talked about grouping factoring. This is our third tool with factoring. So we call this the product sum method. Okay. So second degree trinomials, second degree, remember the exponent on the term, have the form x squared plus bx plus c. For example, we have a, b, c are real numbers. So an example of this would be 5x squared minus 12x plus 52. No matter what the numbers are, as long as they are numbers, we have a second degree trinomial. We want to be able to factor this. But if we look at these things just from its appearance, we can't GCF factor it because there's nothing that I can take out of all three of them. There's not an x, there's not a number. I can't group them because there's only 3 of them. What am I going to do? What we are going to be doing is we're going to be taking this middle term, the b term, and we're going to be separating it strategically. That way we can use grouping, because negative 12 can be broken into whatever we want. It could be negative 1 plus negative 11. It could be negative 10 plus negative 2. It could be negative 15 plus 3. It doesn't matter. It adds up to negative 12. We have all these possibilities to choose from, but we want to choose one that's going to help us use grouping properly. So, what we call the product sum method. Here's what you're going to do. There's a lot of information that I'm about to throw at you, but then when we do some examples, it's going to get a little more straightforward. So if you're not quite understanding it when I explain it this first time, don't fret. So you're going to start by listing the factors of the product of A and C. You're going to find the pair of factors of B, and those are what you're going to separate your B term into. Then you're going to factor by grouping, because then you'll have 4 terms to do the grouping with. So essentially, if I have, let's say, I have this for an example to do quickly. You're going to take the factors of the products of A and C. So here I have A, B, and C. So my product is going to be 1 times 24, which is 24. Separate into the factors. Well, I know the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. We'll make this dun, dun, dun. I don't know how that works. Works perfectly. I want to, I'm just going to change this to a plus just for the purposes of this example. And basically now, I'm finding the pair that has a sum. My sum is 10. Which factors have a sum of 10? Well, 4 and 6 do. That means that 10 is going to be broken into 4x and 6x. So I don't want to break 10 into 2 and 8 or 1 and 9. I want to break it into 4 and 6. I have 4 terms. Now I factor by grouping. Just a couple of general notes. In this example, you had a positive and a positive. That's not always going to be the case. That's actually rarely going to be the case. So there are just some general notes about how to decide which factors you want to deal with. Okay, so here, if your product, you can use this table, and if you want to, you can put this table on your memory aid. But if your product is positive and your sum is positive, both of your factors are going to be positive. If your product is positive and your sum is negative, both factors are going to be negative. If your product is negative, but your sum is positive, one of each. So one's going to be positive, one's going to be negative, and the bigger number is going to be positive. If your product is negative and your sum is negative, you're going to have one of each. So one factor will be positive, one factor will be negative. That's how you get a negative product. And the bigger factor will be negative. So again, I just threw a lot of information at you.
Miss?
Yes.
What's the sum? So what do you mean by product? Like, what's the number that's considered the product?
The number that is considered the product is you take A and C and you multiply them. That's your product.
Okay, and the sum?
The sum is B.
The sum is like the 10, right? That you did.
The 10.
Yeah. Okay.
Just before we actually do this with polynomials, maybe we'll do this with a couple of numbers. I'll give you say a product of -50 and a sum that is equal to 23. So it doesn't really matter. What you do is always you list the factors of 50. 1 and 50, 2 and 25, no 3, no 4, 5 and 10, no 6, no 7, no 8, no 9. So this is what we've got. Because this is negative, this is positive, I go to my chart and I say, okay, my product is negative, but my sum is positive. It means one factor is going to be positive and negative, and the bigger factor is positive. So I go down my list and I say, okay, the bigger factor is going to be positive, but negatives on the smaller ones. And then I see which one of the pairs up to 23. Now when I split this, I'm going to split this as -2 and 25. Let's do another one. have a product of 120 and a sum of -2. What you do again is you break this into factors. 1 is 120. I'm going to make this -120. 2 and 60, 3 and 40, 4 and 30, 5. And 12. These are all the factors of 120. Now, I have -120 that I want to be dealing with, and I have a negative sum. So I go here back to my table and I say, I have my product is negative, my sum is negative. I'm going to have one of each. And the bigger factor is negative. So I go to my table and I say, okay, the bigger factors are going to be negative. So this column is going to be negative. Which one of these pairs has -2? So I'm going to split this into 10 minus 12. So we're going to be using this product sum idea in order to factor these trinomials. Always refer to that table, because this table is what's going to help you make decisions about what should be positive and what should be negative. If you do it with this table, by all means, it just gives you something to refer to. Okay. Let's do some of these examples. We have a whole bunch to go through, just to make sure we're comfortable. So in this first one, your product is always going to be A times C. So if you remember, we have AX squared plus BX plus C. Okay? So your product is going to be A times C, which in this case is 1 times 6, which is just 6. The sign is super important. So what I do is I list the factors of 6. 1 and 6 and 3. I have a positive product and a positive sum. My sum is going to be 5. So I go to my table and I say, okay, I have positive and positive. That means factors are both positive. So I don't have to do anything. I just have to choose them. Which one adds up to 5? Well, these two do. So x squared plus 5x plus 6. This 5 gets broken into 2x, 3x. And now, because I have 4 terms, I can factor by grouping. So here I can pull out an x, leaving me with x plus 2. So, leaving me with x plus 2. And then I can regroup saying, well, I have the x plus 2 in both, x plus 3. So this is factored. So the reason we need to find these two out, we can't just split this into 4 and 1 or 6 and -1. We can't just do what we want, is because these are the only two numbers that will allow us to do this properly. Answer. So you have to find the two. It's like doing a little riddle. Like I have a product of this, I have a sum of this. What two numbers am I looking for? But I just gave you a formula to solve your riddle every time, or a table that solves your riddle every time. Okay? Let's try 3. So remember our product is AC. So this is 6 times negative 30. So in this case, my product is negative 180. Break this into factors. So I've got 1, 180, 2, 90, 3, 60. Have to check it out. Sometimes you'll have to use your calculator and do some calculations. 4 is 45. 5 is 36. 6 is 30. Oh my gosh, we're gonna have a good list for this one. Don't have 7 and 10. We have 10 and 18. 12 and 15. We're good to go. So I have my sum is negative, my product is negative. So I go to my table and I say my sum is negative, my product is negative. So I have product negative, sum negative, means that the bigger factor is negative. So back to my list and I say the bigger factor is negative, meaning I have this, done, done, this whole column goes negative. Which one, just like this, will add up to negative 3? $12 and negative 15. Meaning that this 6x squared splits into 6x squared plus 12x minus 15x minus 30. Am I unfrozen? Did I freeze for everybody?
No.
No, you're okay now, miss.
Pardon?
You're okay now.
I'm good now?
Yeah.
Okay. So here we have the product of negative 180. So we have negative, some negative. Someone's not muted. Thank you. So the bigger factor is negative, 12 and negative 15 works, so that's how I split. Now I can factor by grouping. First 2, I can pull out a 6x, and I'm left with x plus 2. And here I can actually pull out a negative 15, and I'm left with x plus 2. This regroups, so I pull out the x plus 2, and I'm left with 6x minus 15. And this is factored. I'll give you a minute or two to try number 4, and then we'll take a look at it together. So not frozen, just waiting for people to complete number 4, and then we're going to go over it. Phew, excuse me. Alrighty. Just about ready?
Yeah.
Fantastic. Alrighty. That equals 8 times negative 15. So I have negative 120. So I list the products out. Never forgetting 1. 2 and 60. 3 and 40. 4 and 30. 5 and 24. 6 and 20, 7, no. 8 and 15. 9, no. 10, no. Cool. A product of negative 120. The sum here is negative 14. So go to my chart. Product's negative and a sum negative. So the bigger factor is negative, meaning that on my list, these are all going to be negative. So the
Miss,
reason
I think you were freezing a little bit there.
Okay, so I'll go back over that. So we have a product of negative 120, sum of negative 14. So according to my chart, I have that you're going to have one positive factor, one negative factor. And because the sum is negative, the bigger factor is going to be negative. So then we go down here and I make this whole list right-hand side negative. Why? Because 3 times 40 gives me negative 120, and 5 times negative 4 gives me negative 120. So you need one of the factors to be negative. Which factor do I need? I need the pair that's going to give me negative 14. What pair added together gives me negative 14? Well, this gives me negative 119. This gives me negative 58, negative 37, negative 26, negative 19, negative 14. So this gets split. Like this. And now I find my grouping. So here I can take out a 2x, and I'll be left with 4x plus 3. Here I could take out a negative 5, and I'm left with 4x plus 3. And this gets regrouped. 4x plus 3 and 2x minus 5. This is backward.
Miss, I'm sorry, for some reason I can't see your screen. It's all black.
Is everyone having this problem?
No.
Because my second computer is not. So maybe just refresh your screen. right, try to refresh it and let me know if you still have some issues, okay? All right. Let us try 5 and 6. So I'll give you
Miss,
2 or 3. Yep.
how come you chose 6 and 20 for the factors and not 10 and negative 12?
Because what do 10 and negative 12 add up to?
Wait, sorry, you just cut off.
10 and negative 12 add
Yeah.
up to negative 2, right?
Okay.
The sum that I have is negative 14. So that doesn't work for me.
Okay.
The sum that I want is negative 14, and the only factors that give me that are 6 and negative 12.
Okay. Thanks.
So take 2 minutes, try number 5 and number 6, and then we'll take a look at it again.
Miss, when we're grouping, does it matter like the order?
It's not.
No? Okay.
No, so when you've identified your factors, it doesn't matter which one you put first. All right, so even if you're not done, we're going to take a quick look at these together and then have some leftover ones to look at on your own. So here I have a product of 3, because I have the 5 and I have the 6. I have 1 and 30, 2 and 15, 3 and 10, 4 and nothing, 5 and 6. To this, I have a sum of 17. So if my product is positive, my sum is negative, product positive, sum negative, factors are both negative. So everything's negative. Which one gives me a sum of negative 17? This guy. This becomes negative 2x and negative 15x plus 6. Factor by grouping. Here I could pull out an x, leaving me with 5x minus 2. Here I could pull out a negative 3. I don't need a bracket on that. Negative 3, and I'm left with 5x minus 2. These get pulled. This is my answer. This is factored. Example here. Have a product of 6, so 2 times 3. 1 and 6, 2 and 3. So the product is positive, the sum is positive, meaning that factors are both positive. Cool. I don't have to touch anything. I just choose. I see that I want 7, so I want 1, and I want 6. So I have 2x squared plus 6x plus x plus 3. I'm going to group this. Couldn't you just make the x negative and the 3 positive? Hold on, I think I have a question about the last. Which question are you referring to when you ask, couldn't you just make the x negative and the 3 positive? Here? This question? Or the question before? Okay. You could have. Then you would, then in the end, you'd probably end up pulling out another negative. So it's just easier to try to do it this way. So I'll give you these as matching, but try not to use negatives if you don't have to. Alrighty. So here we are, we've just identified our factors. Now we're going to group. So this one, I can pull out a 2. That leaves me with x plus 3, and by 2 I meant 2x. Here, not much I can pull out. So I'm going to pull out a 1, because you have to have something there. When I regroup, I get x plus 3 and 2x plus 1. All right, so we just learned about a whole list. We learned about 3 different tools for factoring. GCF factoring, factoring by grouping, and this is the product sum method for trinomials. Now just quickly, copy this down. But these special cases are really another tool for us to be factoring with. So when we have perfect squares or we have a difference of squares, those are also things that we can use to factor. Because what we're going to be doing now, we're going to do 1 or 2 problems where you're just given something and it says factor. You're not going to be told which of the tools to use. So you have to know which tools you have available to you to be able to use them. And then the thing we're going to be talking about just after those problems, it's the same case scenario. You don't know which tools to use, so you have to know what you can and you can't do. So you have GCF, you have grouping, you have product summing, you have the perfect squares, and you have difference of squares. These are all tools to use for factoring.
So Miss, can you go back up? Did we already copy this?
We did. I'll give you a minute to copy it. Someone isn't muted.
Okay, thank you.
You're welcome. So this is basically just formalizing what we actually did yesterday with the perfect squares, saying, okay, we had those problems, we factored it, but you had to pay attention to make sure that you actually had a perfect square before you factored it.
Miss, what's a perfect square?
Perfect square were these ones?
Yeah.
These things here. See something, remember the ones we did yesterday where it looks like this? So we factored it, for instance, 9x squared plus 6x plus 1, where we said, okay, this I'm going to square root it. That gives me 3x. This I'm going to square root it 1. This is a plus, so this is a plus. I check to make sure. Is 3 times 1 is 3, times 2 is it 6. Yes? We factor that term.
Okay, thanks.
The thing is when in doubt, when you have something like you're really not sure, this can be product summed. When in doubt, use the product sum method. All right, so let's take a quick look here. Just problems where it says, have fun, factor, figure it out. Here's number 1 and number 2, and then we'll go from there. So basically it says factor. Do what you got to do. So your first, like I said yesterday, your first line of defense is GCF factoring. So here I'll GCF factor. So of these, I can remove a 3,
Miss, what page is that?
Yes. We're back on class 4. It was the next page after the problems.
Okay, thank you.
You're welcome. So I can remove a 3x squared. Here I'm left with 2x squared plus 3x plus. Now I have the tool in my toolkit that says, well, this is a trinomial. I should be trying to product sum that. So I have a product of 1 times 2, which is 2. I have factors of 1 and 2. My product's positive, my sum is positive, everything's positive. This is what I'm going to work with. Work within my bracket and say, all right, this gets broken into 2x plus 1x plus 1. And then I regroup within the inside. So I'm just going to make this big bracket so it's clear. Here I can pull out a 2x. I'm left with x plus 1. Here I can take out a 1. I regroup this, x plus 1 that I pull out. I'm left with the 2x plus 1. So this is the factored version of this. So notice how no one's going to tell you, no one's going to say, hey, difference of squares, hey, product sum. Yes?
Miss, I don't know why, but there's something wrong on my computer because every time I'm clicking on your screen, it's black and getting frozen and I can't get it to refresh.
Are you using Google Chrome?
Yeah.
Is anyone else having this problem?
No.
Everyone else fine? I would recommend restarting your computer and then trying to join the call again. Because if you're the only one having this problem, it probably has something to do with your computer. Okay, try that out and let me know when you rejoin the call. Let me know if it works.
Okay.
Okay? Why don't you think you should restart his computer? But then he can just join the Hangout again from Google Classroom. But that may be the issue. We're going to see what happens. We're pretty much, that's the only, I think it's the only option that we really have at this point right now. So we'll see what happens and then we'll go from there. That's true too. So worst case scenario, the live stream is available after the class. Okay. 2. We have this. We have 2 terms. What does our brain go to first if we have 2 terms? Difference of squares. We check. Is this a perfect square? Yep. Is this a perfect square? Yep. So I could take out factoring this. Remember our difference of squares factoring. I take the square root of the first, which is x squared, square root of the second, 1's minus. Now I'm about to tell you something and you need to pay very close attention. Just because you've done this once doesn't mean you don't do it again. In this is a binomial. There's no GCF, and it's not a difference of squares. So there's nothing I can do, so I leave it alone. This, however, is a difference of squares. So this also needs to be factored, just like we did before. Dun, 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 dun. Square root of the first, x. The second, 2. 1's plus, 1's minus. They love to do this.
I do have a question. How come the first one wasn't, but the second one was? A difference of square.
The squares, this has to be a minus.
Okay.
There's nothing you can do. And I'm telling you right now, they love to do this. They love to throw in a difference of squares in a difference of squares. So you have to pay attention for that. Okay. I also love to do this. Let's take a look at number 4. So in number 4, this is hard to see. You always start line of defense number 1, GCF factoring. Because right now, this is not a difference of squares, but it is. So if I GCF factor this, I'll take out a 2x squared. Actually, it's not a difference of squares. My bad. That's okay. Get x minus 9. Could have been, could not have been. So your first line of defense is GCF factoring. Then you basically go with what you can do. Product sum, grouping, perfect squares, or difference of squares. Now, I know we haven't done a lot of examples of putting all the types of factoring together, but what we're about to look at together now does all of that. This entire unit is going to be factoring, 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 and factoring, and just a whole bunch of stuff put together. So we're about to get a lot of practice on this. To that end, we are going to start talking about rational expressions. I'll give you a minute to copy down the blue, and then I'll talk about it.
Okay.
All right, so I'm going to start explaining while you finish copying down. Just as a polynomial. So, what are rational expressions? So a rational expression is made up of a polynomial divided by another polynomial. For example, if I have x squared plus 3x minus 10 divided by 3x 4 plus 2x squared minus 7x. So I have a polynomial divided by a polynomial. So we're going to be doing things like fractions. So this is a fraction, but instead of number on top, number on bottom, we have polynomial on top, polynomial on bottom. So a lot of the things that you've done with fractions in the past, we're going to be doing with these rational expressions. So our main goal, just like with fractions, is to reduce to the simplest form possible. Because just like with fractions, if you want to deal with 100 over 200, you'd much rather deal with 1 over 2. So we're doing the same thing. We want to have the simplest form of the rational expression possible. But a problem we have now that we didn't have with fractions is what we call a restriction. So if you have your calculator beside you, type in 10 divided by 0, okay? So if you try to type in 10 divided by 0, it'll give you an error. Because it is not mathematically possible, unless you're talking calculus terms, to divide by 0. And the problem now is when we have x values in the denominator, we can set x to whatever we want to set it to. And it's possible that somehow whatever x we choose may set the denominator equal to 0. Now, because this is not mathematically possible, we have to find a way to fix this issue. So a restriction is any value for the variable that sets the denominator equal to 0. So we have to identify these restrictions, or be capable of identifying these restrictions. In order to do this, what we are going to do is factor first. So everything we do with rational expressions, from here until we finish the unit, factoring is your first move. For the restriction, if the question just says identify the restrictions, all you have to do is factor the denominator. Because if you type in 0 divided by 10 on your calculator, this is 0. So this is not a problem. The top of being 0 is not a problem. The bottom being 0 is. So in order to just identify the restrictions, we're going to factor the denominator. All of the separate factors equal to 0. Solve for all the restrictions and make a list. So this is where our tools for factoring come in. You're going to be given a rational expression, and you're going to be asked to do something with it. It's not going to say this. It's going to say find the restrictions or solve or whatever. So you have to use all your tools of factoring to be able to do this. So we have a whole bunch of rational expressions here to work with. So this question says, list the restrictions for the following expressions. Now, according to our list, we don't care about the top right now. You are going to factor the denominator. So you go through all your different tools. I have 2x minus 1. Can I GCF factor that? No. Can I group it? No. Is it a difference of squares? No. Is it a perfect square? No. Is it a trinomial? No. So this is factored. What we do now is we just set this equal to 0. Solve. I'll bring this 1 over. And then I divide by 2. So if I put in x's 1/2 into here, I'll make the denominator 0 and give me a problem. So that is my restriction. So I write restriction. Use these squiggly brackets. Or you could say, this is actually a better way to write it. X cannot be 1/2. Because if x is 1/2, that gives us an issue. I got a question earlier today about one of the problems that you had in the quiz that said, given the denominator is not equal to 0. This is what they were referring to. So they didn't want to say, oh, the restriction is blah, 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 blah. So they're saying, we've taken care of your restriction. We know that there's a problem. It's fine. Just do the problem. Because if they don't say that, then you have to identify the restriction. So they're just saving you that pain. All right, step 1. We don't care about the bottom. At top, we care about the bottom. Bottom, I look, GCF factoring. So I can pull out a 4, I can pull out an x cubed, and I can pull out a y. That'll leave me with x minus y. Now I need to identify all the factors. Well, 4 doesn't give me a problem. One factor, this is one factor, and this is one factor. So separately, I have factor 1, I have factor 2, and I have factor 3. So factor 1, x cubed equals 0. So x is 0. That's how I solve. Number 2, I set the second factor equal to 0. Enough. And 3, x minus y is equal to 0. Which means that x is the same as y. Will give me a value of 0. All I do now is say my restriction. X cannot be 0, cannot be y, and a y cannot be 0. Those are my restrictions. And that's it. So factor, set the factors equal to 0, and solve. Let's try the bottom 2. Bottom is what gives me a problem. Okay. This is GCF factoring. So someone asked me to re-explain number 2. This is GCF factoring. So I pulled out for the x cubed, the y, and I'm left with x minus y. So this actually means 4 times x cubed times y times x minus y. Meaning that I have a 4 as a factor, an x cubed as a factor, a y as a factor, and an x minus y as a factor. So separately, I need to take each of those factors and set them equal to 0, because whatever value is equal to 0 is a restriction for me. Meaning I can't have that. So I set the first factor equal to 0, so x cubed is equal to 0, which means x is 0. That will give me 0 on the bottom. The second factor equal to 0, well, that's just y. And the third factor equal to 0, so equal to y, this is going to disappear and give me 0. Things that give me a problem are 0 here, x can't be y from here, and y can't be 0. If any of these things gives me a problem, I'm doing something that's mathematically impossible. All right, let's try another one. Okay. We have binomial. I have to factor this. So I'm going to product sum. No GCF for me to do, but I can product sum. So I have a product of 12. 1 and 12, 2 and 6. 3 and 4. This is negative, this is positive. If you look on your chart, that means all of these are negative. What does that give me? This. So x squared minus 3x minus 4x plus 12. I regroup x, x minus 3. Here I could take out a 4, negative, and I regroup. Meaning these are the factors I have that set the bottom of the equation equal to 0. So these are the factors that I have to deal with. So this is factor 1, and this is factor 2. So I set factor 1 equal to 0. If I move this over, that means x is 3. I set factor 2 equal to 0. So x is 4. What this means is my restrictions x cannot be 3 and x cannot be 4. Because if x is 3, this bottom becomes 0. Problem. If this x is 4, bottom becomes 0, also a problem. So we'll do the last one. I go through my toolkit. 1, can I take out a GCF? No. I cannot group. There's only 2. I can't product sum. There are only 2. It's not a perfect square. Is it a difference of squares? Yes, it is. So this, I take the square root of the first, gives me x. Square root of the second, 2. One's a plus, one's a minus. Factor 1 and factor 2. From factor 1, x plus 2 equals 0. Bringing this over, x is negative 2. It's a little weird because the negative and the 2 got stuck together. Factor number 2, x minus 2 equals 0. So if I bring this over, x is equal to 2. What this means is x cannot be 2 and x cannot be negative 2. Otherwise, my denominator becomes 0 and I have a huge problem. Factor, set the factors equal to 0, state your restrictions. So this is a new thing that you didn't do with fractions before. And this is the only thing that's new. So each of the other things that we're going to do with rational expressions are the different things that you learned how to do with fractions. We good to move on? Okay. Definitely don't need to go that small. So the next thing you did with factors was simplifying the factors. Constantinos, are you still having a problem? He left the group chat.
Miss, how do you know what numbers to factor? Because on question 2, you left out the 4.
4 is just a number. So the reason we have a problem is a variable, because I could set the variable to any number I want to set it to, but 4 never changes. So I don't care about 4 because 4 is 4. It's never going to give me a problem. But depending on what I set an x to be, that could give me a problem, or a y to be, that could give me a problem. So I ignore the numbers because it makes no difference. Okay, so here we go. The next thing we did with fractions was we reduced fractions. So like I keep using this example, but still the same thing. 100 over 200 reduces to 1 over 2. Now, the long way of doing this is saying, well, 100 over 200 is the same thing as 1 times 100 and 2 times 100. So actually these factors cancel out to give me 1 over 2. When you write dividing by 100, dividing by 100, this is actually what you're doing. You're doing it shorthand. So kind of like with radicals, we are separating it into factors that can cancel out and reduce. So this is what we're going to be doing with rational expressions. You're going to factor now the numerator and denominator. You're going to restrict expressions if necessary. Some of the problems will say, if you have a big problem, it'll say, given that the denominator is not equal to 0. And you're like, cool. So given that the denominator is not equal to 0, you don't have to state the restriction. If it doesn't say that, you do. Any factor that is present on the bottom and the top gets canceled out, and that's how you simplify this. Okay, so let's take a look. I'm just going to home page. Dum, dum. And I'm going to do some room to work here. Basically on the side, what I'm going to be doing is I'm going to factor each of these things. So I'll work here with x squared minus 8x plus 15 needs to be factored, and x squared minus 7x plus 10 needs to be factored. So this is why I said we're going to get a ton of practice with our factoring. Here, my product is 15 because I have 1 times 15. So I have 1 and 15, 3 and 5. This is positive. This is negative. That means that all of my factors are negative, referring back to your chart. So I choose this because I'll add to negative 8. So I have x squared minus 3x minus 5x plus 15. Regroup. Factor out things. I'm going to be doing these steps really quickly now because this is our focus is on the rational expressions. If at any point you need clarification, please feel free. So we have x minus 5 at the top, x minus 3. So those are our top factors. We're going to do the same thing here. So my product is 10. So I have 1 and 10, 2 and 5. My sum is negative, meaning these are all negative. And I have these 2. So x squared minus 7x plus 10 separates into x squared minus 2x minus 5x plus 10. I remove the x, remove the 5, I regroup. If I'm going too fast, please let me know. But like I said, we're focusing on the rational expressions. This will come with practice and time. So this is my rational expression factored. Now, if I want to state the restrictions, I would go over here. I would say 1 and 2 because this is my denominator. So x minus 5 equals 0, meaning that x can't be 5. And x minus 2 equals 0, so x is 2. So my restrictions our x cannot be 2 or 5. Because if x is 2, this denominator goes to 0. If x is 5, denominator goes to 0. I go back to the rational expression itself. Okay. I want to reduce it, meaning any factor I see that is both at the top and the bottom goes away. So I have an x minus 5 here and an x minus 5 here. What this leaves me with is x minus 3 divided by x minus 2. And this is reduced. Let's try number 2. So number 2 here, I have 2x squared plus 7x plus 3 as my numerator. My product is 2 and 3, 6. Because I've already checked, there's no GCF to remove. It's a trinomial, so this is what I'm going with. So I have 1 and 6. That's not a 1. 1 and 6. 2 and 3. Positive, positive, all positive. I got this one. So this splits into x and 6x. So I have 2x squared plus x plus 6x plus 3. Here I can take out an x. I'm left with 2x plus 1. Here I can take out a 3. And I'm left with 2x plus 1. 3 groups to 2x plus 1, x plus 3. So that is what I have at the top. At the bottom, for x squared minus 1, there's no GCF. I can't group, I can't product sum, nada. This is a difference of squares. This square rooted, this square rooted with a plus and a minus. So this is what we get on the bottom. Before we reduce, we need to state our restrictives. 1, 2. So 2x plus 1 equals 0. I move that over. 2x is 1. Divide by 2, so x is 1/2. 2x negative. Thank you. 2x. Oh my goodness, just ignore me for a second here. 2x minus 1 equals 0. 2x is positive 1 this time for real. And I divide by 2. So x is 1/2. Fractions. X cannot be 1/2 or negative 1/2. Here, we see factors that are present in both. I take this one and this one away. I'm left with x plus 3 over 2x minus 1. That's it. So you factor. This is why I said to you, your tools for factoring are super, super important. So the GCF, product sum, grouping, difference of squares, perfect squares, all of these things are super important for you. Make sure you can handle them completely properly. What we are going to be doing is we're going to be continuing on with rational expressions tomorrow. There are a couple of things that we have left to do. we have multiplication, division, and addition, subtraction. They're very, very similar to fractions. And then we're going to do one little thing at the end of tomorrow's class, and then we're done with the algebra portion of this. So we'll be moving on to something a little bit different as of next week. So at around 12:30, your assignment for today will be posted. This afternoon, I will be posting the notes for tomorrow's class, so keep an eye out for those. And if there are any other questions about any of the problems or the assignments, please, please, please send me an email. And other than that, I hope you have a fantastic afternoon. Enjoy your afternoon class if you have one. And other than that, enjoy the beautiful sunshine. And we will see each other tomorrow.
Thank you.
Thank you.
Thank you.
Bye, guys.
Thanks, Miss.
You're welcome.